morning. Okay, welcome back, Cookie. So this is our second time. Okay, so let's start. We have daily news science technology, genetic mapping unveils layered neuron patterns in memory centers. This correct? Uh, So same as usual, Cookie. I'll read the meaning and please read the sample sentence after the audio. Is it good? And US and UK or US only? Okay, sure. Okay, so we have the first one. It's a verb. Here is it.
Suspect.
Okay, it means to think that something is likely to be true. Okay, here's the sample sentence.
Many experts suspect that climate change will cause more storms.
Okay, next up we have adjective.
Underlying.
Underlying, positioned under the surface of something.
The underground tunnels lie in the underlying layers beneath the city streets.
Okay, we have verb this time.
Represent.
Represent means to be a sign or example of something.
The painting represents the struggle between good and evil.
Mhm. This time we have noun.
Signature.
Signature, a special quality or feature that makes something easy to recognize.
Her smile is the signature that everyone remembers about her.
Mhm. And last one, finally, still a noun.
Resolution.
Resolution, the level of detail that can be seen in an image or a screen.
This camera has a resolution that captures sharp and detailed images even in low light.
Okay, that's all, Cookie. Let's have the questions in the comprehension part. Let me read twice. Number one, what does the hippocampus do? And how did the scientists see the layers? And what might the finding help explain about diseases? Okay, so let's have now the audio of the article. Okay, here is it.
Genetic mapping unveils layered neuron patterns in memory center. Scientists have discovered something new inside the brain that helps explain how memory works. The discovery was made in a part of the brain called the hippocampus. This part helps with learning, remembering places, and emotions. This area was once thought to be mixed, however, it is actually well organized. Researchers found that the CA1 region of the hippocampus has four thin layers of brain cells. Each layer has a different job. These layers change slightly as they run through the brain. This means different parts of the hippocampus help with different tasks. Researchers have long suspected that different parts of the hippocampus CA1 region handle different aspects of learning and memory, but it wasn't clear how the underlying cells were arranged. Our study shows that CA1 neurons are organized into four thin, continuous bands, each representing a different neuron type defined by a unique molecular signature, said the senior author of the study. To see these layers, scientists use special tools that let them look at gene activity inside single brain cells. This made the layers look like stripes, similar to the layers of rock on Earth. When we visualized gene RNA patterns at single cell resolution, we could see clear stripes, like geological layers in rock, each representing a distinct neuron type, said a researcher on the team. This finding may help explain why diseases like Alzheimer's affect some brain cells more than others.
Okay. Do you want to listen again or let's go to the question quickly? Okay, so question number one, what does the hippocampus do? Okay, that's it. And of course, it's on first paragraph. You got it. And how about this one? How did the scientists see the layers? Okay, so this time it's on fourth paragraph, still correct. And last one for the comprehension part. What might the finding help explain about diseases? Okay, so fifth paragraph this time. Thank you, Cookie. You got all the answers correctly. So, of course, we will proceed to read out and then, of course, discussion after reading. Okay, so you can start. Okay, thank you, Cookie. Honestly, it's clear so far because I usually take down notes, but as of now, we don't have mispronounced words. So I guess we need to move on to discussion part. We got six questions. Okay, let's try the first one. So, Cookie, would you prefer a research institution to focus its resources on A, discovering new diagnostic methods for a disease, or B, developing new treatments for a known disease? And why is that your preference? Exactly, especially cancers, right? So it's very famous nowadays, and it's hereditary also. So in our family, Cookie, we have history of breast cancer. So that is why um I'm really scared of having that one also, right? So my father's sister died 3 years ago because of breast cancer. So I need to be careful. Right? So I think it's really famous nowadays, and I don't know why cancer has been famous for a long time, but still no. As of the moment, I think there's not enough cure for that, or I don't know what's the real situation about the treatment. Right. Mm. Later part. Mhm. Yeah, exactly. That is why we need to be conscious all the time, right? Like uh last one, I'm also a teacher in school, and one of my new workmates, she's around 50 years old, and she discovered the cancer, I mean the breast cancer late. But according to her, one time, he touched something in this area, and it's already big. So can you imagine? It's big already. So meaning she's not really conscious about herself, right? Because, it, I mean, the cyst is big already. So meaning it's been there for a longer period of time. But she discovered it just last uh this year. I think that's January. So that's why I really agree with you. It's about how you discover and treat the cancer at an early age, right? That's very important. Okay. But you know what, Cookie? Sometimes I'm really scared about checkup because I'm scared that the doctor will discover something like new, something like that, right? So it's it's wrong mindset. But yeah, so I'm really scared that, oh, you have this disease and you have this illness, so that is why I have that fear of having checkup also. But it's really important. Yeah, that's it. Okay, here's the sample answer, and you can check later on. Let's have the second question. We have, do you find it easy to remember places you have visited before? Why or why not? Is that the case? You know what? That's my problem even before. So when I'm married already when I studied college. So I have this classmate who's really having a how can I say? Having a lot of groceries, cookies, and of course, whenever we feel hungry and we have vacant time, we visited his boarding house. So I think that's 3 times a week. So most of the time we were in his boarding house, but with classmates. So I went in that area with classmates within the university area only. But then, uh, starting from first year to fourth year, but then one time I went there by myself and I get lost. So until now, I don't know what's the reason, but it's really hard for me to locate a place. Maybe I will not be lost if I will really remember this area is having this sign or having a particular tree. So if I have particular symbol, if I will really have a particular symbol, yeah, I can locate that area. But most of the time, I get lost in terms of places. So I think I have problem in terms of the hippocampus or something, right? So that's because in terms of people, I can always remember faces or names, Cookie. But again, it in terms of places, location, um, that's really hard for me. I can always forget the places, locations. Mm. Yeah, not focusing on location, right? Exactly. That's really hard. But of course, as long as you can read and you can ask someone where is this place, so it's fine, right? So it's very important. Okay. And we have the third question. What ethical consideration must researchers think about when using new brain scanning and cell mapping tools to study people? Mm. Yeah. Yeah, exactly. That's very important, right? So the safety first, right? And of course, also the information like data privacy, something like that, right? So it's also considered. I mean, when I was in college, I heard about the study about people who will be awake for a long time, and of course, they use different people who've been awake for 2 days or 3 days or in a week. And of course, if you will be the participant, you have to make sure that you will be safety while joining the experiment or that research, right? Because it's really risky. And based on that result, Cookie, that person who've been awake for a longer time cannot remember anything. So even though they ask very simple question, that person cannot answer. So that's the result of that particular. That's our class in a psychology. That's a psychology class, and accordingly, the result of that study, that person who've been awake for a longer time or days cannot focus and cannot even answer simple questions. Right. So I think the brain is not functioning already. So it's risky, right? And that's why one of the ethical consideration is safety of the participants and, of course, privacy, also data privacy. Okay. So next one, we're on question 4. Do you think mapping the brain's memory layers will eventually allow scientists to delete traumatic or painful memories from a person's mind? Oh, why do or don't you think so? Ah, traumatic memory. Yeah, exactly. I like this. Mhm. We have different traumatic events or memory, right? So I really like this one, but it's really hard to say something about this. But knowing that we have the advancement of technology, so we can really achieve this, removing or erase that particular structure, right? So for me, I agree with this. I mean, I really want this kind of treatment, something like that, right? So okay, maybe in the future. Yeah, exactly. Next one, Cookie. If you had the power to make the hippocampus layers in your brain extra strong in one area, like spatial navigation, math memory, or emotional recall, which area would you choose and why? Oh, I like this. Mm, mm. Wow. I like it. Yeah. Of course, emotional recall is really important, but I like this math memory also because I'm really bad in mathematics. So I like this one. So it's really good, right? So, but of course, we don't have this power. Okay. And let's have this quickly, Cookie. If scientists can map the physical location of your memories, what does that change about how you view privacy and the security of your mind? Cookie. We're running out of time. Thank you for the second